We're on.
Okay, we are talking about human population, page 100, section 4.2. And it's an important section because human population is doing something now it's never done. It's climbing at a rate faster than it's ever climbed or will ever climb. It's going to have to slow down in the future.
Thanks, the girls like Sophie.
Oh, did you hear? Sophie's welcome another one to the world's in.
Sophie's pregnant.
What?
Sophie's just...
Hey, y'all,
Kidding.
You know how that happens?
calm yourself.
First of all,
Thank you.
you guys from?
Let's let me talk.
After your...
Let's let me do the talking. That'll be easiest.
Your child? Oh, that's news to me.
There were others.
I thought it was just immaculate.
Okay, if we look at the human population, what we see is a steady population. We are on page 100. A steady population of somewhere around 20 to 50 million people. Going all the way back when people first evolved.
Did the first person look exactly like us?
Well, people, if you remember when we talked about human evolution, remember all those chapters we did on that? I don't want to get back into that. But the population of humans was steady for a very long time. But when we hit the Industrial Revolution, suddenly there became widespread energy available, widespread food due to farming, improved farming techniques. And suddenly the Earth could support a lot greater population. Also, in the modern age, we've hit medicine. We've had antibiotics and that sort of thing, medicines that weren't available, so people are living longer. And this contributes to this huge population expansion. Now, they're expecting, according to this graph, it levels off around 12 billion people. But we don't know that for sure. That's just a guess. Some scientists have estimated that the Earth could hold up to 30 billion people. And others think it's less than that. Right now, if you're wondering, we're at about 6.8, I think, 6.5, something like that, billion people. When I was y'all's age, it was 4 billion. I remember learning that in high school. Yes?
I have two questions. One, why do they say we're going to level off at 12?
Well, again, just like populations we studied last section, there's always a carrying capacity. There's a certain limiting factors that prevent populations from growing forever. Space, pollution, lack of food, not enough water, that kind of thing, will limit the population growth at some amount. Where that amount is, we don't know, but they guess maybe 12 billion. And like I say, some people say no, maybe it can go all the way up to 30 billion. But it has to stop somewhere because there's just not enough space.
Right.
Yeah.
And also, in our book, it doesn't show it level.
Oh, really?
Yeah.
Interesting.
You can see it kind of curving, but different way.
Yeah. I don't know why. Zero population growth occurs when the birth rate equals the death rate. We don't have that right now in most places, but in some countries you have that. Most countries you have more births than deaths, and so you don't have this zero population growth.
Doesn't somebody die like every 5 seconds?
Someone's born every 2 seconds.
Here we see different countries. You see Afghanistan, 4.77% is their growth rate. That means their population increases by 4.77% per year?
Slow down.
No, it should be per.
Couldn't be per year.
Per, that's right.
I don't know if that's per year. Anyway, you can see this Germany's got a 0 growth rate, and that means that their country they just have just as many births as deaths. Afghanistan has a lot more births than deaths. Bulgaria has more deaths than births, so their population is actually going down. And you can see where the United States ends up. Most of the population growth in the country is in Africa.
When was this made?
This book is like 3 years old. This is, you're looking at what's called an age structure diagram. And you have to be able to read these things. On the left side of these stacks of blocks are the males, and on the right side are the females. Now, these numbers here are age ranges. And the size of the box tells you what percent of the population. For instance, for this country, the country that these blocks represent,
Kenya.
people from age 0 to 4, females from age 0 to 4 make up 9% of the population. Males from age 0 to 4 make up almost 10% of the population. You see? And you can see in this age structure diagram that looks like a
Eiffel Tower.
yeah, like a
Pyramid.
pyramid. Looks like a cone or a pyramid.
A golf team.
You can see that it's wide on the bottom, thin on the top. That will tell you just by looking at it that it's a growing population, because a lot of kids are being born and fewer are dying. Different than, say, Germany. Oh, that's Kenya, they've said. That's an African country there. Germany is few kids being born, about the same many kids as old people. So for every new kid that's born, you got old people dying. And so that kind of evens out. That's a 0 growth rate. In the United States, we see has slow growth. It's a little wider on the bottom than it is the top, but not much, so that's slow growth. So the wider it is on the bottom compared to the top, the faster the growth. And so we are seeing a great number of humans being born. And the question that the book asks is, what's worse, having this huge increase in a country like Kenya, this huge increase of people, or just a moderate increase in a country like the United States? The difference between people in Kenya and people in the United States is people in the United States use a lot more resources. One American uses as much energy and electricity and oil and such as maybe 30 Kenyans. So there's a problem with both people in less developed countries and more developed countries. LDC means less developed country like Kenya. Look, even though the population of places like Kenya is much greater than places like us, we use more of the fossil fuels, more of the metals, and more of the paper than those countries. And this is a short video about that. It's from a movie called People Bomb.
Picture the developing world. Too many people on the edge of survival. Fouling the land, water, air. Compounding a crisis of poverty. It is the very face of overpopulation.
But what about this? It's a middle-class suburb outside San Francisco called Pleasant Hill, and it really is a nice place to live. Nice houses, nice cars, plenty to eat, the size of an average household, about 2.4 people. Certainly a place like this has nothing to do with overpopulation, or does it?
What you got to remember is that overpopulation is not just an issue of how many people there are.
Not only of how many people there are, but of how much impact each person has.
These are the bakers of Pleasant Hill. Ellen, Dan, and their 2 children. They don't plan to have any more.
No. I don't think of ourselves as being overpopulated. I come from a very large family, so 2 kids is a very small family to me.
These are the Quairols of Gorkha, a crowded mountain village in Nepal, one of the poorest countries in the world with one of the fastest growing populations. So far, Sukuyama and Gopal Quairol have had 6 children, the national average. Which of these 2 families, which of their nations, would you call overpopulated?
Generally, one can say that the birth of a baby in the United States is on the order of 30 times as big a disaster for things like global climate change, the ozone layer, acid precipitation, and so on, as a baby born in a poor family in Nepal, Bangladesh, Colombia, or wherever.
According to the UN, the industrialized world, with only a quarter of the planet's people, uses 3/4 of its energy. 85% of its wood products, 72% of its steel. It also spits out 3/4 of all carbon dioxide emissions. Half the damaging greenhouse gases in the atmosphere.
The single biggest impact that makes the United States overpopulated is that it's 240 million people driving cars. And 240 million people driving cars are incredibly more damaging to the planet and the environment than billions of people who don't drive cars.
The Quairols of Nepal don't have a car. The Bakers have 2. The Quairols walk to work in the fields and everywhere else they go. The Bakers belong to a society literally designed around the automobile.
It isn't just the things that's spouting out of the tailpipe of the car or off of the brakes or the rubber that's evaporating into the atmosphere as it drives. It's also, of course, the costs, the environmental costs of building the automobile.
But it's around the house that the disparity becomes even more clear. The 8 members of the Nepali family live in a hut made of some wood and a lot of mud. They prepare their sparse meals, heat and light their home with fuel wood, candles, and a little kerosene, all of which have some negative impact on the environment. But compare it to the family of 4 in the USA, living in a house made of wood, steel, and hundreds of pounds of plastic.
For which we had to refine oil and produce various toxic chemicals which have been dumped into aquifers.
So what's for dinner?
The house in Pleasant Hill is filled with gas and electric appliances.
Turn on a light and what you get is a nice glow and you're able to read by it and that's fine. What you don't see is the places that are strip mined to produce the coal to ship to the power plant.
Every time they wash the dishes, they probably turn on a gas burner or an electric burner and put out a lot of CO2 into the atmosphere.
The Bakers are conscientious waste recyclers with special bins for cans, bottles, and newspapers. Still, the very lifestyle that demands such materials traps them in a cycle of environmental destruction.
There really is no way to throw anything to in this world, and right now we are sending ships and trains all over the place to carry garbage from American cities to other parts of America.
In Nepal, what little trash the Quairols generate goes to feed the animals or into a compost pile. When there's little to have, there's hardly anything to throw out.
And certainly, any member of the family in Nepal would probably rather be living the way that family in Pleasant Hill is. But the fact remains, it is families like that family in Pleasant Hill whose numbers and consumption are threatening the survival of the planet.
So who's overpopulated? The rich, developed nations like the U.S., where fertility rates are low and there's plenty of food and opportunity? Or poor, struggling nations, where the birth rates are sky high and there's not enough to go around?
We're both overpopulated. The planet's overpopulated, but our overpopulation is a greater problem for the planet than their overpopulation.
Interesting. it's good. It's a good idea to understand human population growth. This is where all pollution problems arise. Back when there were this many people, there was no pollution. You could just throw stuff in the woods or in the water. The oceans were big enough, whatever you threw away would float away or sit in the woods and not be a problem. Now, there's people everywhere. You can't just throw stuff in the water. It flows downstream to where somebody else is living. You can't just throw stuff in the woods. It's probably somebody's property. It's a lot more crowded than it used to be. So now we have these problems like pollution and such. So what's going to happen is, as the carrying capacity gets reached in the human population, we're going to start running out of food. Pollution is going to get a worse and worse problem. We're going to have to do something about it. And just like all natural populations do, when they reach that carrying capacity, a lot of individuals die. Now, humans are smart enough to see this coming, unlike a population of rabbits or something like that. And humans can control their own reproduction. So what we see some countries doing that really have the problem with this, like China, is they try to control their reproduction, not have so many kids. And the way they've done that, or they were doing that, was they instituted laws that limited the number of kids you can have. If you have too many kids, you get heavily taxed. And so people don't want to have so many kids. And that will control the population. And that's what you're going to see more and more of. Because, and you see more and more famine and diseases going around and things like that, problems with having too many people. So it's interesting. And all of this stuff that I'm showing you on global warming is due to high human populations. Each person burns about 3 tons of carbon a year just to produce electricity to run their stuff. And that goes in the atmosphere, and that 3 tons isn't that much. But if you consider 6 billion people, that's 18 billion tons a year of carbon, and that will thicken your atmosphere. Yeah?
A couple of years ago, I went to Mexico, like a museum, it's a long story, but I went to Mexico City, and then we went up like a mountain near it, and there was like so much smog over the city.
Oh, yeah.
Like a black cloud.
Yeah, there didn't used to be smog.
If you see like
Smog comes from a lot of people.
Yeah.
if you're like driving up and you see the city of Atlanta, it's just ridiculous.
Yeah.
The smog.
My sister lives in LA, and for a while I went over there to visit her, and a couple of the days the sky was brown. It wasn't blue, it was brown. You could just look up and it's brown. It's gross. You see people walking around there wearing gas masks. It's not how I would want to live. That's one of the reasons why I don't live in a big city. But it's just different.
People walk around wearing gas masks?
Yeah, walk around the city with a gas mask on.
Why?
A lot of pregnant women do it because the air there is so polluted. They don't want to hurt their developing fetus. Okay, we're going to continue with this. You can cut the video off now, Heather. Thank you very much. Make sure you all read 4.1, 4.2. And we're going to continue here.
Mr. Willis, you have to say what you say.
Wheel us out.